And we're now recording. All right, so while I'm getting set up, planning for now until I decide otherwise to do one section a day, at least for this week. Okay, so the adjusted schedule is 9.3 today. So my goal for this week is 9.3 today, tomorrow 9.4, Thursday 9.5. Okay. So again, it looks like I'm falling behind, but I'm not. I got all these extra days at the end. I'm using up maybe a couple of them now. Okay, reminder, next week on Thursday, there's no class at all at CSM. So, okay. The most likely scenario is the exam will be the week after on Thursday, the 29th. I'll announce it, later. But the coverage would be 9.1 to 9.5 and just two sections in chapter 10, 10.1, 10.2. It's still trig. Okay. By the way, we're finally off trig, I think, at the end here. Okay, so the last test will cover non-trig stuff. Okay, quick word on today's assignment 9.3. I'm throwing out the last problem, 33. So skip 33. It's really just going to be 1 to 31 odd. Okay, so once again, 9.3. The original was 1 to 33 odd. Make it 1 to 31 odd. I'm going to skip problem 33. All right, so my goal for today is to do enough of 9.3. And if I have time left over, maybe I'll sneak in a little bit of 9.4. Okay, again, I can't really do one section a day because I have to leave you time to do a quiz on Thursday, obviously. So we'll see how that goes. So if I can sneak in a little bit of the next day, that's fine. Okay, and then after this week, we only have 1, 2, 3, 4, 5 weeks. 5 weeks for this many sections here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 sections left. Okay, so again, if I do about a section a day, then of course, there's a day for a couple of exams too that we have to think about. But I think we're going to be okay as it stands. All right, so let me get started without further ado with where we were. So 9.3. So the original schedule is pretty much out the window now. I was able to keep it quite a bit here, but I wanted to slow down since I had the time. When spring break came around, I said, okay, I got all these extra days, so I'm going to start using them. So I'm slowing down considerably. So the old schedule is pretty much forgotten. Like, I'm just going to cross this out now. And we'll just go by what I have over here. Yeah, and forget about this. So we are here, 9.3. All right, so as I mentioned last time, 9.3, we have all these other messy formulas also. So put these on your next cheat sheet. Page 620, product to sum and sum to product formulas. Okay, product to sum, product means you're multiplying something, and you can write it as a sum. Okay, these are derivations of the previous formulas. They can be proved. I can show it to you if you want to. I doubt anybody will take me up on it. I checked them for myself. Okay, but essentially, if you have a product of sine times sine, or sine times cosine, or cosine times cosine, they give you the formulas there. Okay, so where is it again? Bottom of 620. You say, I don't have the book. You got the video right here, so you can check the video. Kind of messy. They all have a half in front of it, right? So 1/2 the top one, sine A, sine B, 1/2 cosine A minus B minus cosine A plus B. Second one is 1/2 sine A minus B plus sine A plus B. And the last one is 1/2 cosine A minus B plus cosine A plus B. So you have to look in those problems, is it sine times sine, sine times cosine, or cosine times cosine? And by the way, in case you're wondering, suppose it says cosine times sine. Well, cosine times sine is the same as sine times cosine. So you just switch them around and then use the formula. Okay, so those are product to sum. They can be proven. They are variations of the previous formulas. Again, this page, 616, has a lot of formulas. You're welcome to put all of them on your cheat sheet. Okay, but let's say the formulas that we have today are 8A, B, C, right? You can derive them from previous formulas. Okay, so in particular, if you look at equation 5 formulas especially. Okay, 5, A, B, C, D, E, F. If you combine them the right way, you can get those formulas. And then number 9 the sum to product formulas. Okay, that's what we're doing today. But I'll go ahead and show it to you in our current section. So page 622. Okay, again, those are alpha and beta. The first two letters of the Greek alphabet. Well, the beta is kind of obvious. It kind of looks like a funny looking B, but the other one doesn't look that much like an A. Well, maybe it looks kind of like an A, but anyway, that's alpha. Alpha and beta. Okay. Side note, that's where we get our English word alphabet. We say alphabet comes from the first two Greek letters in the Greek alphabet are alpha and beta. So we have our English word alphabet, right? But in any event, I'm not testing you on that, of course, but all right. So we have four forms here: sine alpha plus sine beta, sine alpha minus sine beta. And then the same thing except for cosine. Cosine alpha plus cosine beta, cosine alpha minus cosine beta. Okay. So you just look for the right one. Does it look like sine plus sine, sine minus sine, cosine plus cosine, cosine minus cosine? So these are called sum to product. You started with a product, I would start with a sum, make it a product. Okay, so here they are: 2 sine alpha plus beta over 2, cosine alpha minus beta divided by 2. Second one, 2 cosine alpha plus beta over 2, sine alpha minus beta over 2. Third one, 2 cosine alpha plus beta over 2, cosine alpha minus beta over 2. Last one has a negative in front of it, negative 2 sine alpha plus beta over 2, sine alpha minus beta over 2. So you just look at the problem that they give us, and then I ask myself, which of the 7 does it look like, right? So does it look like sine times sine, sine times cosine, which includes cosine times sine, cosine times cosine? So one of those 3, right? Or like this. Does it look like sine plus sine, sine minus sine, cosine plus cosine, cosine minus cosine? Just pick the right formula and just plug it in. Okay, I'll show you at least one of each example. All right, so here we go. So let's get started. Problems were, it was originally 1 to 33, it's now 1 to 31 odd. 9.3, page 625, okay? So just up to 31. So here we are. And you should be able to see 31 there. Yeah. And I told you skip 33. It's beyond what I want to do. Okay, so again, I'll show you at least one of each type. All right, so number 1. Use a product to sum formula to convert each expression to a sum or difference. Simplify when possible. Okay, cosine 70, cosine 20. So number 1. Cosine 70 degrees times cosine 20 degrees. All right, so that looks like cos. So which one looks like cos? The bottom one, right? So let me write that for you. So I'll write the formula. Cosine A, cosine B is 1/2 cosine A minus B plus cosine A plus B. Okay, that formula goes, right? So this is my A, this is my B. So I'm going to go 1/2 cosine of the difference. Cosine 70 minus 20 plus cosine A plus B, 70 plus 20. Going it right into the formula. All right, so 70 minus 20 is 50, 70 plus 20 is 90. So 1/2 cosine of 50 degrees plus cosine 90 degrees can't do anything with this, but we can do the cosine of 90 degrees. Standard position, 90 degrees right here. What is the x coordinate? 0. So this is 0. So I'll just write 1/2 cosine 50 degrees. That's my final answer. So just take what they give me. They gave me cosine, cosine. So I say to myself, okay, which one looks like cosine, cosine? Third one down. Okay, so I wrote the formula for that. Plug in, right? So A is like 70, B is 20. So put 70, 20, 70, 20, 70 minus 20, 50, 70 plus 20 is 90. But I know the cosine of 90 is 0. So 1/2 cosine 50 degrees. That's the way it goes. All right, number 3 is sine, sine. Sine 5 degrees, sine 85 degrees. Sine, sine. Okay, so look at my formulas. Which one goes sine, sine? First one, right? I'm on page 620. But again, actually, it might be better if you just want a composite of all the formulas. You can look at that other page. What was it? 616. So it has a whole bunch of formulas, right? Including, just they call them 8 and 9. That's the ones we're doing today. So sine, sine. So let me write the formula for that. Sine A times sine B (1/2) cosine A minus B minus cosine A plus B. That's the first one there. Sine times sine. All right, so this is my A, this is my B. So 585, 585. Okay. So I'm going to go 1/2 cosine of 5 degrees minus 85 degrees minus cosine 5 degrees plus 85 degrees. So 5 minus 85 is negative 80. Minus a cosine of 5 plus 85 is 90 degrees. We just did this, right? Cosine of 90 degrees is 0. Cross that out. Okay. And cosine is an even function. That means the cosine of negative 80 degrees is the same as the cosine of 80 degrees. So the best final answer is 1/2 cosine of 80 degrees. Okay. Cosine of negative an angle, the same as the cosine of an angle. Those are the negative angle identities. Cosine of negative theta equals cosine of theta. Cosine of negative 80 degrees, same as cosine of 80 degrees. In fact, I can show you even here. 80 degrees is like that. So negative 80 degrees would be like that, right? They have the same x coordinate by symmetry, right? So let's say this is positive 80 degrees, negative 80 degrees. Okay, they have opposite y coordinates, but they have the same x coordinates, right? These two x coordinates would be the same. So here's the best final answer for that one. Okay. I'm sorry, that wasn't problem 2, that was problem 3, I think. Did I write it incorrectly? Yeah, I got it right. That's number 3. And 5 has the mixture, sine, cos. Sine 20 degrees, cosine 10 degrees. So sine times cos. Sine times cos. Second one, right? So it's 1/2, blah, 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 blah. So let me write that one down. Sine A cosine B equals 1/2 sine of the difference, A minus B, plus sine of the sum, A plus B. That's my A, that's my B. So that's going to be 20 minus 10, 20 plus 10. So 20 goes here, 10 goes here, 20 goes here, 10 goes here. Is that right? So 1/2 sine 20 degrees minus 10 degrees plus sine 20 degrees plus 10 degrees. All right, so that's equal to 1/2 sine of 10 degrees plus sine of 30 degrees. This one I can't do anything. This one we should recognize. Sine of 30 degrees. Draw my unit circle. 30 degrees, 1/3 of the way up. Again, for the angles that have a reference angle of either 30 or 60 degrees, either X or Y as 1/2, just determine which one it is. That looks like a Y coordinate of a half. X coordinate is the other number. The other number is always radical 3/2. All right, so the Y coordinate at 30 degrees is 1/2. So just change it to 1/2 and that's about it. So 1/2 sine of 10 degrees plus 1/2. And that's my final answer for that one. All right, so I've shown you one of each of those, but they were all in degrees. They do have some in radians now. Okay. So to be fair, I should do some with radians. Okay. Again, at least one of each type. Okay, so let's see, 7, 9, and 11 are in radians, and then give you some miscellaneous ones here and there. Okay. So how about I do 7? Cosine pi/5, cosine 4pi/5. Cosine pi/5, cosine 4pi/5. Okay, cos, that's this one. Right, so I just peek over here and do the same thing. So that's my A, that's my B. So 1/2 cosine of the difference plus cosine of the sum. So cosine pi/5 minus 4pi/5 plus cosine of the sum pi/5 plus 4pi/5 like that. Okay, pi/5 minus 4pi/5 is negative 3pi/5. Pi over 5 plus 4 pi over 5 is 5 pi over 5, which is pi. We do know cosine of pi. 180 degrees, x coordinate. What is the x coordinate right here? -1. And again, cosine of negative an angle is the same as the cosine of the angle. Cosine is an even function. So I can write -3 pi over 5 as the same as positive 3 pi over 5. So final answer is 1/2 cosine 3 pi over 5 minus 1. Final answer. Like that. Okay. Okay, 9 sine 2 pi over 7, 5 pi over 7. Okay, sine. That's this one. So 1/2, they all seem to have a half. Cosine of the difference minus cosine of the sum. So cosine, subtracting 2 pi over 7 minus 5 pi over 7 minus cosine of the sum minus cosine 2 pi over 7 plus 5 pi over 7. So again, when it looks like sine something times sine something, that's like this, sine A, sine B. So 1/2 cosine of the difference, so I subtract them, minus cosine of the sum, so I add them up. Okay, so 2 pi over 7 minus 5 pi over 7 is a -3 pi over 7. Minus cosine of 7 pi over 7, again, that's cosine of pi. We just did cosine of pi. That's -1, but I'm going to have a -1. It's a double negative, so it becomes a positive. Okay, and once again, I'll make that a positive because the cosine of negative an angle is the same as the cosine of the angle. So final answer, 1/2 cosine 3 pi over 7 plus 1. Plus because I have -1. All right, then the mixture one, how about a sine and a cosine? So 11. Yeah. If it looks like I'm doing all the problems right now, you're right. I needed to show you one of each type, but that might end up I'm doing all the problems. So that's fine. Again, there really shouldn't be any reason why you can't do, 70% of the homework, because I sometimes end up doing 70% or close to that, or maybe even more of the homework anyway. Okay, sine 7 pi over 12. Cosine pi over 12. Sine times cosine. That's this one. So 1/2 sine of the difference plus the sine of the sum. So 1/2 sine of A minus B. So I subtract them. 7 pi over 12 minus pi over 12 plus sine of the sum. 7 pi over 12 plus pi over 12. Okay, that's going to be what? 6 pi over 12? Pi over 2. Eight pi over 12. Three. We can figure both of them out, right? Pi over 2 is 90 degrees right here. 0, 1. Y coordinate is 1. 2 pi over 3 is right there. Y coordinate does not look like a half. X looks like it's negative half. So it's got to be the other number. 1 plus radical 3 over 2. Okay, so final answer, 1/2, 1 plus radical 3 over 2. You can leave it like that, but if you want to distribute it, that's okay too. All right. All right, they give you a few which just don't have any specific angles, but letters, like 13, 15, 17. You just got thetas and such. Okay, so maybe I'll show you how to do one of those. Okay, so how about I'll show you maybe 15, sine 6 theta, cosine 5 theta. All right, so what does that look like? Sine, cosine. So I'm using this one. So it's 1/2 sine of the difference. 6 theta minus 5 theta. Sine of the sum. That's it. So 6 theta minus 5 theta is theta. So 1/2 sine theta plus sine 11 theta. That's about it. So that's it for the first set, 1 through 21, where the product is sum. Okay, what time is it? Yeah, plenty of time. The remaining problems are the other way around. Sum to product. Okay. Sine plus sine, sine minus sine, cosine plus cosine, cosine minus cosine. Okay, so I'll try to show you at least one of each. Okay, I'm finished with the piece of paper, so let me do my focusing thing again. So it's everything we've done today so far. So that, and then over here. Okay. All right, so the problems we've done up to now, 1 through 21, were so-called product to sum. And the remaining problems go the other way. Okay. Sum to product. So we're using one of these guys. Okay, so again, just pick out the right one. Does it look like sine plus sine? Does it look like sine minus sine? Does it look like cosine plus cosine? Does it look like cosine minus cosine? And then they give you the formulas. Okay, so again, I try to show you at least one of each. All right, so, whoops, where'd it go? Yeah, 23. Cosine 35 plus cosine 55. Okay. 23. cosine 35 plus cosine 55. Right, cosine plus cosine. Third one down, right? 2 cosine alpha plus beta over 2, cosine alpha minus beta over 2. Okay, so let me write the formula first. Cosine alpha plus cosine beta, 2 cosine alpha plus beta over 2, cosine alpha minus beta over 2. So this is like alpha, this is like beta. So here we go, 2 cosine alpha plus beta divided by 2. So I add them up, 35 plus 55 divided by 2. And then cosine of the difference, 35 minus 55 divided by 2. Okay, 35 plus 55 is 90. 90 divided by 2 is 45 degrees. (35 minus 55 is a negative 20. Negative 20 divided by 2 is negative 10. Cosine of 45 degrees. 45 degrees, remember both x and y are the same number, radical 2 over 2. So 2 radical 2 over 2. And once again, cosine of negative 10 degrees is the same as the cosine of 10 degrees. Cosine being an even function. And looks like I can cancel the 2's here. So radical 2 cosine 10 degrees, final answer. Like that. All right, that's how that one goes. 25. Looks like sine minus sine. Okay. Am I doing a huge percentage of the problems? Yes, I am. Let me make it better for you. Sine pi over 5 minus sine 3 pi over 10. Sine minus sine. Sine minus sine. Second one, right? Sine of alpha minus sine of beta. And there's a formula, which I will not write. Sine alpha minus sine beta. 2 cosine alpha plus beta over 2 sine alpha minus beta over 2. Okay, so this is alpha, this is beta. 2 cosine, add them up and divide by 2. Okay, pi over 5, I'm going to treat it as 2 pi over 10 to get a common denominator. Right? Do you agree? Pi over 5, multiply top and bottom by 2, 2 pi over 10. So I'm going to have 2 pi over 10 minus 3 pi over 10 divided by 2. Oops, I'm supposed to add it. My bad. Plus. This one's a plus. And then sine of the difference divided by 2. 2 pi over 10 minus 3 pi over 10 divided by 2. So it's a little bit clumsy. Let's see. 5 pi over 10, right? 5 pi over 10 is pi over 2. Two pi over 10 minus 3 pi over 10, negative pi over 10. Divided by 2. I think I've shared with you this trick. When you have something like this 2 can just slide down on the bottom. This 10 can just slide down on the bottom. In other words, just pretend it's 2 times 2 or 4. And this is 10 times 2, which is 20. So 2 cosine pi over 4 sine of negative pi over 20, like that. Okay, cosine of pi over 4, we just saw that, radical 2 over 2. Sine is an odd function, so the sine of negative pi over 2 is the opposite of the sine of pi over 20. So I'm going to go 2 radical 2 over 2 times negative sine pi over 20, like that. 2's cancel out. Put the negative in front of the whole thing. So final answer is negative radical 2 sine of pi over 20. Okay. All right, so we have cos plus cos, sine minus sine. So I guess we need to do a sine plus sine, and also a cos minus cos. Okay, and let's see what time it is. Go a little bit longer than the break. Okay, let's look for a cos minus cos. How about 27? Cosine 5 theta minus cosine 3 theta. Cos minus cos. Cosine alpha minus cosine beta. That's the bottom one, right? Fourth one down. Negative 2, blah, 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 right? Let me just write it down first. Negative 2 sine alpha plus beta over 2 sine of alpha minus beta over 2. That's my alpha, that's my beta. So negative 2 sine alpha plus beta. So I add them up. 5 theta plus 3 theta divided by 2. And then sine of the difference divided by 2. So 5 theta minus 3 theta. 5 theta minus 3 theta divided by 2. Okay, so 5 theta plus 3 theta is 8 theta divided by 2, 4 theta. Sine of 4 theta, and 5 theta minus 3 theta is 2 theta divided by 2, you just have theta. So that's it. All right. And one more to show you, which is a variation on the theme. 29 is a little bit trickier, but they do give you a hint. Sine of 35 plus cosine 65. They say use identity cosine theta is sine of 90 minus theta. Okay, so what do they mean by that? Sine of 35 plus cosine 65. So you might recall one of the identities, cosine of 65 degrees is the sine of 90 degrees minus 65 degrees. Okay. Cosine of an angle is a sine of its complement, 90 minus that angle. Let me just see if I can show that to you in here somewhere. Yeah, that would be 4D and C. They got it in radians, pi over 2, but pi over 2 is 90, right? Sine of 90 degrees minus theta is cosine theta, and vice versa. For D, cosine of 90 degrees minus theta is sine of theta. Pi over 2 is 90, right? So in other words, I can make that the sine of what, 25 degrees? I should separate, this is scratch paper. So essentially I have sine 35 plus sine 25. Which essentially means I have sine plus sine. So I've shown you one of each. Okay, so let's say we got cos plus cos, sine minus sine, cos minus cos, and now this is the one that's sine plus sine. Okay, so we would have done it all. So sine plus sine, top one, sine of alpha plus sine of beta, 2 sine blah, 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 blah. Okay, so let's write that down. Sine alpha plus sine beta, 2 sine alpha plus beta over 2, cosine alpha minus beta over 2, right? This is alpha, this is beta. So I'm going to go 35 plus 25, 35 minus 25, right? 2 sine of alpha plus beta, 35 plus 25, divided by 2. Cosine 35 minus 25 divided by 2. Okay. All right, 35 plus 25 is 60. 60 divided by 2 is 30. $35 minus 25 is 10. 10 divided by 2 is 5. Can't do anything with that. We can do something with this. Sine of 30 degrees. Y coordinate. Looks like it's a half, halfway up. Two times a half. Cosine of 5 degrees. Well, the 2 times a half just cancels out. Cosine 5 degrees. That's it. All right, so I'm actually done with the section, folks. So after the break, I'll sneak in a little bit of 9.4 and we'll probably end early like other days. Let me do my focusing thing again for this side. Although I'll probably do it one more time before I'm done. There we go. Okay, so usual break until about 12:10ish, all right? Okay, so break. Okay, folks, I'm going to try to get started. I won't go that much longer since I've already covered everything I was going to do. So rather than just quitting now and being letting you out extremely early, I'll sneak in a little bit of the new stuff and we'll still get out early. All right, so my original game plan was just do 9.3 today. I've done that. But as long as I have the chance, I might as well sneak in a little bit just in case something goes wrong later. So I'll get you started with 9.4 and it will just make things a little bit easier tomorrow and or the next day. Okay, so 9.4, we're doing trig equations. You'll be happy to know there's no more new equations that you have to worry about. You do have to worry about thinking about your unit circle and so forth. Part of this is calculator dependent, so you have to have your calculator handy for some of this section. Okay, so let's see where we are. I'm going to mark off 9.3. We're finished with it. So you have 1 to 21 odd, 25 to 51 odd. Okay, I'll do very few today, and I'll do a lot more tomorrow. Okay, so 51 is the highest problem we got to do. Page 637. Okay, there's all that. And over here. All right. Get you started on some of this. Now, problem 1 and 3 is blah, 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 a solution of the equation. It basically means you're just plugging it in and then saying, is it true or is it not true? Okay, so 1 and 3, I'll do one of them. Let's see, number 1 has cosine, number 3 has tangent. Why don't I do the tangent one, number 3? It says, is blah, blah, blah a solution of the equation? Okay, let's try it. So 9.4, which I don't really want to use green. Page 637. Okay, question 3. They give you x equals 3 pi over 4. The question is that a solution? Which means just plug it in. It's either true or it's not true. So all you do is just try it. So tangent squared x minus 3 tangent x plus 2 equals 0. 3 pi over 4 is over here. Second quadrant. So the tangent of 3 pi over 4 is -1. Okay. The ordered pair is negative radical 2 over 2, radical 2 over 2. So again, all the angles that have a reference angle of 45 degrees, here, 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 and here, both x and y are plus or minus radical 2 over 2. Just make sure what quadrant you're in. 3 pi over 4 is quadrant 2, so x is negative, y is positive. Therefore, the ratio, which is what the tangent is -1. So you're basically going -1 squared minus 3 times -1 plus 2, which is 1 plus 3 plus 2, and that's not equal to 0. So the answer is no. No what? No is not a 3 pi over 4 is not a solution to this equation. Okay, that's all. All right. Show you how to do a couple of these, and maybe I won't go that much longer. So 5 and on. Determine all solutions of the given equations. Express your answers in radian measure. Okay, so I see some sine and see some cosine and I see tangent. Okay, maybe I'll just do one of each, and that will be good enough in preparation for tomorrow. Okay, so I'll do one of each. Sine of theta, radical 3 over 2. Y coordinates is radical 3 over 2. Now, we're not that comfortable with radical 3 over 2, but we are more comfortable with the number that it's always paired with on the unit circle. It's always paired with plus or minus a half. Okay. Now, sine is a y coordinate. Where is the y coordinate positive? 1 and 2. So I would go to 1/2 and -1/2 for x. So right here, the y coordinates are radical 3 over 2. All right, so what is this angle? Looks like 60 degrees, pi over 3. This looks like 120 degrees, 2 pi over 3. So in one revolution, once around, pi over 3, 2 pi over 3. However, in the directions, it says determine all solutions. Well, you know, if I just keep going around multiples of 2 pi, I will land in the same spot as here or here. So let's say you land at pi over 3. If I add 2 pi, I still land here. Add another 2 pi, it's still here. And you can go backwards also. So the way you write that is pi over 3 plus 2k pi, or 2 pi over 3 plus 2k pi, where k is an integer. So that gives you all the solutions. Pi over 3, 60 degrees. And then you go around multiples of 360 degrees or 2 pi radians. So if I add 2 pi, I'm here. If I started by adding 2 pi's or 4 pi, I'm here. Another 2 pi would be 6 pi and 8 pi and 10 pi. And you can go -2 pi, -4 pi. So in general, you write 2k pi. You can also put 2 pi k. But 2k pi is the normal way to write it here. And do the same thing for 2 pi over 3. So 2 pi over 3 works, but I could take 2 pi over 3 plus 2 pi, plus another 2 pi, 4 pi, 6 pi, and -2 pi, and so on. So best final solution, theta is pi over 3 plus 2k pi, or 2 pi over 3 plus 2k pi, where k is an integer. I should put theta equals also. Theta equals. Okay. All right, so that's a sine type. I'll do a cosine type now. Number 9, cosine theta is -1. Cosine of theta is -1. X coordinate is -1. Where is the x coordinate -1? Well, only right here, right? So what is the angle? Pi. So for one revolution, I would just have pi. But again, you can keep going around multiples of 2 pi, either forward or backward. So theta is pi plus 2k pi, where k is an integer. By the way, how does that differ from here? Because within one revolution, you have two such values. There are two thetas where the y coordinate is radical 3/2. There's one in the first quadrant, one in the second quadrant. This one, however, where on a unit circle is the x coordinate -1, only here in one revolution. So I just have pi, and then I add another 2 pi and another 2 pi, or go back 2 pi, and so on. So pi plus 2k pi, where k is an integer, and that's sufficient. That's good enough. All right, so I showed you a sine, showed you a cosine, I'll show you a tangent, then I'm done. Okay, so if you have any questions, prepare them in the next few minutes. Otherwise, I'll be done and we're finished. Okay, but this one's a little bit harder. Tangent theta is radical 3. Okay, let's see, what quadrants could I be in? All students take calculus. The tangent of the angle is positive. So where am I? 1 or 3? Quadrant 1 or quadrant 3? Now, you can memorize the angle. I don't like to memorize it. I'd rather just work it out. So I'll show you a slick trick for working this out. Okay, tangent is which trig function divided by which other trig function? Sine theta over cosine theta is radical 3. I'm going to write it as radical 3/1. Here's the trick. Divide both the top and the bottom by 2, like so. And why? Because it works. That's only the first quadrant angle. And then if I pair them, I have sine of theta is radical 3/2. And at the same time, cosine of theta is 1/2. All right, x coordinate is 1/2. X is 1/2. That looks like 60 degrees or pi/3. Now, what do I have in a third quadrant? Okay, notice that's the ratio. They could also both be negative. So in other words, or sine of theta is negative radical 3/2, and cosine of theta is negative 1/2. All right, so again, I want the ratio to be radical 3. So the easiest one is if they're both positive, but if they're both negative, that also works. Okay, and yes, that's going to be quadrant 3. X and Y are both negative. So x coordinate is negative 1/2. So I go halfway this way and I come down. So I have this corresponding angle, which is 180 degrees or pi radians off of it, 4 pi/3. That's one revolution. pi/3, 4 pi/3. So at first glance, you might say, oh yeah, pi/3 plus 2k pi, just like this, or 4 pi/3 plus 2k pi, just like this. But in this particular case, you can write it better because how far apart are these angles? Pi/3, 4 pi/3, and if I keep going around the circle, they are exactly 180 degrees apart, or pi radians. In other words, if I start here, I add pi, I get the other solution. Add another pi, I'm back here. Add another pi, I'm back here. So better to just take multiples of pi in this instance. So theta is pi/3 plus not 2k pi, but just k pi, where k is an integer. Again, what's an integer? Integers are 0, plus or minus 1, plus or minus 2, plus or minus 3, no fractions, no decimals. So this is more compact. Say pi/3, add a pi here, add another pi here, another pi. Okay, and of course you can go negative. So the best way to write this is not to do this, okay, but theta is pi/3 plus k pi. So when the angles are 180 degrees apart from each other, this is the way to go. Okay, in case you're wondering, you say, how come you didn't do that over here? Well, I wasn't allowed to. Okay, these are not 180 degrees apart. I can't combine this into one because that would be pi over 3, but it's more than pi over 3 until I go all the way back around the circle, right? So this is as good as it gets. Theta is pi over 3 plus k pi. Okay, and I'm finished, folks. So I'm going to do my focus job, and then I'm done. So in a few seconds, I'll be finished. If anybody has a question, you can put it in the chat or else unmute yourself. But otherwise, we're done for the day, and I'll just pick up from here tomorrow. Thursday's quiz, I'll give you a quiz on stuff we've done this week and last week, you know, maybe like the sum and difference formulas. Basically, you can just use the formulas on that one page if you want to prepare for it, so-called. And there we go. Okay, so yeah, in terms of what I might give you for the quiz on Thursday, something involving that big page with that, all those formulas there, right? So I'm going to find that for you again. 9.2, page 616. Something from this big thing here. So you just pick the right formula, plug everything in, and go from there. So that's what I'm aiming for Thursday's quiz. All right. So I'm done, folks. Anybody have any questions about anything? Either put it in the chat or unmute yourself. Okay, I don't see or hear anything, so we're done for the day. All right. Have a good afternoon, everybody. We'll see you tomorrow. Okay. Bye, everybody.